This video demonstrates how to use National Instruments Multisim simulation software for electrical and electronic circuits. So the first thing that we want to do is open up Multisim. So if we select our Windows key here and just type in multi or just even mult, it should pop up here. You see there's a National Instruments Multisim app using version 14.0 here. And so when you open this up, it opens up in a blank design screen, and so we can start adding components. So the first thing that we want to do is come over here. If you look at the toolbar, you see there's several different components categories that you can select from. So the first thing we want to do is place source. So we're going to select the sources. Now once you open this, if you decide you need something else, you can actually change your group. Right here under the group, you can select a different group of items. You can kind of choose a subset of those by clicking on one of the various items here. So what I want to do is I want to add a DC power source. So I'm going to select DC underscore power, and I'm going to select OK. And now it basically attaches it to my mouse cursor, and I can drag this around and place it where I prefer. Now the other thing that we need is ground. You must have a ground source there. So you for the simulation of this software to work, it needs to know the reference point. So we must have at least one ground in the circuit. Remember that ground you can use different grounds for different applications, but whichever ground that you choose, if you use that in multiple places, that will be the same voltage throughout. So I'm just going to grab the ground and I'm going to paste that. Now notice what happens is after you paste it in the circuit, it pops open the box and allows you to choose something else here. And if you're done, you can just click on close and it'll close there. Before I go any further, I just want to talk about the view area here. If you come over to the view screen, you can of course zoom in and zoom out. And there's also a grid, so you can turn on the grid so you can line things up a little bit nicer if you want. So I'm going to come back over here then, and I'm going to start placing some resistors. Okay, and so when we paste resistor, we're coming here to the basic. We can paste in a resistor, and it'll automatically start numbering these resistors, and it defaults to well, I mean, you can select it when you come in here. You can select what resistance you want, and then it'll just remember that. So as you add more resistors, okay. Now what I do a lot of times, once I get the first one or two resistors in there, I just will come over here and select, and then you can do a Control C, and then you can copy that, and then you can paste another resistor in there. Now this one I'm going to rotate 90 degrees, and then I'm going to copy the rotated one and paste in another one. So I'm just going to do a little 4 resistor circuit here. Notice that you can kind of drag them around after you place them. You just click on them, you can drag them around. Also notice you can change the values. So if you double click on one of the items, you can come in here, you can change your voltage. You can change your resistance. So if you wanted to this 1K here, or if you just wanted to make it 200 ohms, or even some odd thing like 203 ohms, you could just Click on that and apply that. Okay. You can go to label. You can change the label if you want to give it a different type of label or reference description here. And so if you wanted to make this one R5, you could do that. Now it wouldn't let you do like R4 because I already have an R4. I'm just going to cancel that though. I'm not going to change that. All right, so here we have just a little circuit kind of set up here, but I haven't connected anything yet. So what we want to do now is connect these, and if you see over here we have a bus, but we really don't need that. What we do, if you notice, if I bring the cursor right over here to the edge of the resistor, you see it kind of gets a little dot there, and if I click on that, and I can then drag this over. Now, as I drag it over, you can kind of see it making different lines in there. So if you wanted to like stick at a line, bring it over and click on that dot, and that'll hold it to that spot. So it's you know, as you can see here, I'm just kind of going crazy. And then when I click on another item, then it attaches that wire. Okay, now if I want to get rid of that, I can just click on that, and I can just adjust it, or click on it and delete it. We can also kind of click on it when we put it on there. If we right click on it, we can change the color of it. Okay, so you can go in and you can do like color coding here, so you can change the color. All right, so I'm going to just connect R1 to R2. Now, when I want to connect R3 in here. So now notice I can't really click on the wire and drag it to R3. That doesn't quite work. So what you want to do when you want to tie in a third connection is you need to click on that resistor, on the edge of that resistor, and then pull that one up there, and then you can see it gives you a dot showing that that is a connection. Okay, so the same thing like here for the negative side of this circuit here, I'm going to bring this over and I'm going to connect it up to my 10 volts. Now I'm going to click on the ground, bring that up and connect it to that line, and R3 I'm going to bring down and connect to that line. Now if you decide, oh, you didn't want that connection, you can highlight that connection, hit the delete key, and then, you know, move the connection somewhere else if you want it. Notice if I put it over here, it changed it to the blue color. All right, so there is our circuit, and we could theoretically we could come up here and simulate it. All right, but right now it would actually simulate the circuit, but wouldn't give us a whole lot of information. So we can come up here and we can add probes. Okay, so we have a voltage probe. We can come on this and we can put a voltage probe here, and we can click on this voltage probe and place it here, and it'll give us the reading of the voltage. Now notice it gives us a lot of different voltage readings here. It gives us just a general voltage. It gives us a peak-to-peak voltage, an RMS voltage, and a frequency voltage values, which are all dealing with AC circuits, and then it also shows us a DC voltage. So for this circuit, I just have a DC source. I have no AC, so I don't need any of this frequency or whatever. So I'm going to double click on this, pop it open, come over to parameters, and then go to custom parameters, and I'm going to turn everything off except for just the top voltage. Okay, or if you wanted just the DC voltage, but this is just going to be a DC voltage because that's all I have applied. Now that I've done that, I could come and I could select another one of these probes, but then I've got to go select all those parameters again. So it's easier to just click on this probe and then copy the probe and place it wherever you want. And you can have probes all over the place here and measure these voltages. Of course, this should be 0 volts down here. Notice the probe PR4. That should be 0 volts because it is connected to ground, but you know, we can put a probe there and measure it. Now notice these voltage probes are measuring voltage to ground. So if I wanted to measure the voltage drop across resistor R1, which is not attached to ground, then I can't really use the voltage probe. I could do a subtraction if I did like probe R3 minus probe R2, and you know, I could do the math. I'm just going to select everything here and drag it down just a little bit to make a little bit of room here. And I'm going to come up here to Tools, or you can also come over to the right hand side. I'm not sure if it's showing on the screen there really well. Let me move it over a little bit. So you can come over here and there's lots of like measurement type stuff. So I want like a multimeter. So I can either get it over here on the right side, or I can come under Simulate and go to Instruments and select it. All right, but see here I have a multimeter and it's got a positive and a negative. So I can therefore take and connect the positive and the negative ends of this multimeter across a certain segment of your circuit here, and then it'll measure that. So you double click on it and that'll pop open this value. And again, if you wanted to like label this, okay, if you wanted to change the label, you could come in here to the settings, and I thought I could change this label. All right, so I'm not sure if we can change the name of this, but one thing you need to make sure you do with this meter is you need to set it. Are you measuring resistance? Are you measuring voltage? Are you measuring current? And then, like, if you're going to measure voltage or current, you got to choose either AC, which is this sine wave symbol here, or DC. And of course, we just want to do DC. And so we've got that meter. Now, if we wanted to just measure current, you could wire in current using this multimeter, or you could use a current probe. And with the current probe, you could take it here and you set it here. And again, you need to set those parameters. So I'm going to double click on that, go to custom, and I'm going to shut off everything but the main current. Okay, and now notice here, with this current, I've got the arrow is pointing from the right to the left. And so I'm going to copy that. I'm going to put it down here also. And, you know, again, we can just copy these probes and put them wherever you want. So, you know, I've really got a lot of stuff in here, but I'm going to go ahead and hit Run up here. So if you press the green button, you play and it'll do the simulation. And now you can see the values. So here is the voltage. Here's 10 volts. Of course, this voltage is 0 volts. This voltage here is 778 millivolts. And the reason for that is because this is a 200 ohm. Remember, I changed that to 200 ohms. So now notice here, this current here is 778 microamps. Notice that this current is minus 778 microamps because it's going in the current is flowing through resistor R2 into resistor R4. And this probe is pointing the wrong direction. If you right click on the probe, you can reverse its direction and it'll show a positive. Okay, so, you know, if you put the probe in there wrong, it just simply shows that the current's moving in the opposite direction. And so it shows you a negative sign, says that current's flowing in the opposite direction that the probe is flowing. All right, so but you can see that this is less than 1 milliamp here. And yet over here at this probe, we've got 8.44 milliamps. Okay. And again, we can see the voltage drop. You see the voltage drop across just this resistor here, R1, is 8.44 volts out of my 10 volts. And that's why this voltage here, right, this voltage here is 1.56 volts. And this voltage over here at R4 is only 0.778 millivolts. Okay. And again, we could apply Kirchhoff's voltage law, Kirchhoff's current law, and Ohm's law everywhere throughout this circuit and verify all these values. Okay. So if you want to make major changes to the circuit, you need to make sure you come back up here to the stop and stop the simulation, and then you can come in and you can change values of your resistors, or you can change like let's change R3 back to 1K, 1 kilo ohm, 1K, and then do the simulation again. Now you can see that we only are losing 6 volts here across R1. So I have 4 volts across R3, which of course Ohm's law is easy to calculate there. 4 divided by 1000 is 4 milliamps. So there's 4 milliamps running through R3, which leaves 2 milliamps to flow through R6, and then so this 4 milliamps comes down R3, joins with the 2 milliamps coming from R4, and so the total current flowing into and out of the battery is 6 milliamps, right? So there's Kirchhoff's current law, so we can verify that very easily. We can verify Kirchhoff's voltage law. We start here at 0 volts. We go through the battery, so we go up 10 volts. We go across R1 and we lose 6 volts across R1. And then we come over here at R3 and we lose 4 volts. And so we go up 10, minus 6, minus 4 gives us back to 0 volts. So we can very easily see what's happening in these circuits using this Multisim software. Okay. So one of the things we need to make sure that we do with this, of course, after we create our circuit, is we want to save it. And so you can just come in here and click Save, or use Save As if you want to save it to a different one. And then you also want to make sure you don't want to save it on your C drive. So you want to save it to your D drive. So we'll come down here to our D drive, create a directory for this, and save it on here. Give it a name, you know, so this is like, I'm going to, I guess I don't have a folder here, so I'm going to create a new folder and just name that for my name, go into that folder, and then I'm going to save this, and this is just going to be a DC circuit with 4 resistors. Okay, and you know, if you wanted to, you could add in that it's a series parallel circuit or something along those lines. So give it a name that means something, that tells you what the circuit is. If you just call it design 1, design 2, or test 1, test 2, you got a bunch of files that are completely meaningless. So save the file with a name that tells you something about the circuit.